Hello and welcome to today's class. So we are going to look at multiplication of surds. First things first, we're going to handle this example that is the product of surd of 32 and surd of 75. The first thing you want to do is, first of all, make sure that your surd is written in its simplest form before you actually multiply it. And so that's what we're going to start with. So 32 written in its simplified form, you want to think of a number that when we divide by 32, and it has to be a square, will give us a perfect quotient. And that number actually is 16 by 32. So we are going to write 32 in terms of 16. So that's going to be root 16 times 2, okay? And we're also going to do the same for the square root, the root of 75, the surd of 75. So the number, it has to be a square. When we multiply by 75, gives us a perfect quotient, happens to be 25. So when you take 25 times 3, we get 75. Of course, we want to rewrite this. And if we rewrite it, it's going to be root 16 times root 2 times root 25 times root 3. Of course, root 16 there is going to give us 4. Okay, of course, the square root of 16 times root 2 times root 25 is going to give us 5, square root of 25, times root 3, which is a surd there. Okay, so we're going to collect these all numbers together, and basically we're going to have 4 multiplying 5 and times root 2 multiplying root 3. Awesome. So 4 multiplying 5 will give us, okay, 20. All right. And times root 2 times root 3 will actually be root 6. But remember, we are trying to leave our answer in its simplest form. So we won't have it as root 6. So we just have it as root 2 times root 3, which we can simplify to 20 root 2 root 3. And so that's it. That's the product of root 32 times root 75. All right, so that is it for example A. If you have any question around that, maybe you can drop it in the comment section and you'll be up. So for our part B, we are going to handle a very simple problem. Okay, so we're going to try to find the square of a surd. So what if you're given 3 root 7 and you're supposed to find its square? 3 root 7 and you're supposed to find its square. So basically this is the same as having 3 root 7, okay, times 3 root 7. Okay, that is what that means. It's the same as having 3 root 7 times 3 root 7. And so we do the same thing we did with the first problem. We're going to multiply the numbers outside the root by themselves. And so that's going to give us 3 times 3. And then we are going to also have the surds multiplying themselves. So root 7 times root 7 times root 7 times root 7. Okay, so notice this is going to give us 3 times 3 is going to give us 9, and root 7 times root 7 is actually going to give us root 49. Okay, which you can simplify, of course, and it's going to be 9 times root 49. The root of 49 happens to be 7. Okay, so this is going to be 9 times 7, giving us 63, and that will be the product of this particular surd, that is 3 root 7 squared. So that is it for the second example. Again, if you have any question, you can drop it in the comment section. Let's do the last example under this and then look at division. Yeah, for the third example, we are having a root of 12 times 2 root 18 times 20. Remember, for us to multiply this, we have to first of all have these surds written in the simplest form. So this written in its simplest form basically means that we are going to have 4 by 3, 4 times 3. We're going to write 12 in terms of 4 times 3. Of course, that's the I square there. And again, we have to think of the I square that we can actually multiply by 18 to get a perfect quotient. That's going to be 9. And it's going to be 9 times 2 to give us 18 times for 20, the I square that we can multiply by 20 to give us a perfect quotient, that's going to be 4. So that's going to be 4 times 4 times 5. Awesome. So basically that means there that we are going to have root 4, okay, times root of 3, times 2 root of 9 times root of 2, okay, times root 4 times root of 5 there. Okay, so the root of 4 is 2, all right, times root 3 times 2 root of 9 is 3. So that's going to be 2 times 3 times root 2 times the root of 4 here is 2 times root 5. So this basically means that we're going to have 2 times 2 times 3. We are multiplying the whole numbers first without surds. So 2 times 2 times 3, okay, times 2. All right. Now we multiply the surds times root 3, okay, times root 2 times root 5. Okay, now note we are going to have 2 times 2 giving us 4, 4 times 3 giving us 12, 12 times 2 giving us 24 there. So we're going to have 24 times root 3 times root 2 times root 5. So this here can just simplify to 24 root of 3 root of 2 root of 5 as our final answer. All right, so that's it for multiplication. So for our next example, I want to handle division of surds. All right, I want to handle division of surds. Yes, so division of surds. So we are going to handle in this particular lesson intently division of monomial surds. Of course, in the next video, we will look at division of binomial surds. All right, so now when we are dividing surds, basically what we do, we want to make sure that the denominator is not a surd. So that process of making a denominator not a surd is what we call rationalization. So division of surds is also usually referred to as rationalization of surds. Rationalization of surds. Rationalization of surds. So let's go into our first example. And so in our first example, we have been told to rationalize. Basically, we are supposed to make sure that the denominator is not a surd. It's not a surd. We have been told to rationalize 9 root 3. 9 root 3. So rationalize 9 root 3. That is the instruction. So how do we make sure that root 3 here, which is our denominator, is not a surd? So usually what we do, we multiply it by another surd, and it has to be a surd that is identical to it, all right? So that we do not change the value of the whole term as well. So usually we multiply it. In this particular case, we'll multiply it by the surd in the denominator, which is going to be the root 3. And we are going to multiply the denominator and the numerator as well by root 3. Now, I want you to note that by multiplying it by root 3 over root 3, we haven't changed the value, because when you divide root 3 by root 3, you just get 1. So it's the same as multiplying the whole surd by 1, all right? Except that now, with this particular trick, we are able to rationalize the denominator. We are able to make the denominator a rational number and not a surd. Remember, all surds are irrational numbers. All right, so this is going to leave us with 9 times root 3, which will be 9 root 3 all over root 3 times root of 3, which of course is going to be root 9, and that's going to give us 9 root 3 all over 3. Okay, so notice 3 divided by 9 is going to give us 3 root of 3. And so that will be it for our first problem, okay? For our first problem, that's going to be our answer, basically. So that's going to be it for the first one. Now, for the second one, let us look at B. All right, let us look at B and see what we are going to get. All right, so what if you've been told to rationalize 3 root 28? So in this particular class, we'll only look at rationalization of monomial surds. So they're easy to deal with, okay? They're easy to deal with, and that is why you're seeing that these problems are quite simple and right straight to the point. Okay, so for us to first of all rationalize B, we want to make sure that the denominator is in its simplest form. Okay, and so we want to think of a way of rewriting the whole thing with the denominator simplified. And of course, when you're writing it with the denominator simplified, you always want to think of a number that is a perfect square that we can always go ahead, multiply by the whole number, and of course that is going to be, in this particular case, and get a perfect quotient. In this particular case, it's going to be 4. Okay, so when you multiply 4 by 7, you get 28, and so we will rewrite the whole side as 3 root of 4 root of 7. Of course, you know that this is going to give us 3 root of 4 is going to be 2 root 7. And so for us to rationalize this number here, we will simply multiply it by our surd, and that is root 7 in this particular case. So it's going to be root 7 divided by root 7 there. So remember, we haven't changed the value. It's just like multiplying by 1, okay? So that's going to leave us with 3 multiplied by root 7, which is going to be 3 root 7 all over 2 divided by 2 times root of 2 root 7 times root 7. Of course, that's going to give us 2 root 49. Okay, so that's going to give us 3 root 7 all over 2 times 49 there is going to be 7, and note this will give us 3 root 7 all over 14. 3 root 7 all over 14, and we can leave our answer at that. So we've actually rationalized that particular problem. All right, we've first of all written it in its simplest form and then multiplied it by the surd that we got, and that was root 7, the numerator and the denominator. Okay, for our last example, let us look at a situation now when you're given root of I'm thinking of the quickest way to go about this. Let us think of when you're given the root of 25 all over 8. The root of 25 all over 8. Of course, we want to rewrite it. So that it's easy to deal with it. Okay, so remember our rule of thumb. We say that when you're given a root of a fraction, when you're given a surd with the number below it as a fraction, basically you can write it as root 25 all over root 8. Okay, all the denominator as with the root sign, and the numerator also with the root sign. So this is going to give us the root of 25 is going to give us 5 all over the root of 8. Okay, so when you rewrite root of 8 in its simplified form, you are going to get that it's 5 all over 2 root of 2. So I want to believe that by now you are able to do this. So I'm just doing that to jog your memory up. All right, so that at least you're also able to figure out how did he find 2 root of 2. So when you rewrite 8 with the perfect square, then you'll realize that it's going to give you 4 times 2, of course, and the square root of 4 is 2, of course, and then the root of 2 right there. So for us to rationalize it, it means therefore that we're going to multiply the denominator by root 2 and the numerator by root 2. Remember, it's all about making sure that the denominator is not a surd. Okay, that is the essence of rationalization, making sure that the denominator is not a surd. All right, so that's going to give us 5 times root 2. That's going to have 5 root 2. That's going to give us 5 root 2. And then 2 root 2 times root of 2 is going to give us 4. All right, so that's it for that particular problem, and also for this particular class. If you are having any problem, if you're having any questions, drop it in the comment section and I'll get back to you as soon as I can. See you as we handle by rationalization of binomial surds in the next video. Awesome. Adios.